One of the two things that we're most interested in when working on suspension, when you're working on suspension design of a race car, is how evenly the load of the car or the weight of the car is distributed among each of the four tires. Because the more you evenly distribute that weight, the faster your car is able to go around corners, and the quicker your car is overall. Um, However, there are a lot of factors that determine how the weight is distributed on the car, especially when the car is driving around the circuit, and cornering, and the G's you're experiencing under cornering are changing, and we'll discuss all of that. But it's so much that it's tough for us to do in Excel. So I thought for my project I would input a lot of these calculations into MATLAB, and then run it and display it all in a nice graph. So, uh, up here at the start, we have all the input variables that we would control for and are important to these calculations. Um, so we have them in here, and I have just some base numbers input that are representative of like a passenger car and not a race car. Um, but yeah, and then we go down here, and this is the actual run section. We'll run all the different functions we have up here. So we're going to run the function first for static weight distribution. What's the weight distribution of the car when it's just sitting on the track? And then based on the G's of acceleration, of braking, and cornering we're experiencing, um, there are different effects that has on the weight of the tires, and we calculate all those in different functions, and then bring them back into the start code. And with each function, we're updating the loads that are on each tire, and then inputting the same variables into the next function, so they can all be calculated with one run. Um, so once we input all our variables that are important to these calculations and then run the actual calculations, the next step is to go ahead and graph them. So we're just plotting on a standard on a standard plot. We plot each load in the corresponding location for the tire, and then use these functions right here to plot the actual tire. So we can go ahead and run our function, and then we see pretty clear representation of the load in pounds that's on each tire, under the input variables that we put in. And so right now we're saying that we aren't accelerating or braking, but we're cornering with zero point 0.8 G's. Our car weighs 3,000 pounds at the moment. Um, but what this code is really helpful for doing is quickly adjusting a parameter and seeing how the load changes. So let's say we were driving around the racetrack with these loads, and our driver comes back and says, I don't have enough grip on the front axle of the car. Can you distribute more load to the front axle? And I'll be like, yes, I can. Let me see how much I want to do that. So I can change the lateral load transfer distribution to, let's say 55%, or 55%, to 40% in the front, and then I run the code again, and I see that the loads have been updated. So the loads are more evenly distributed along the front axle of the car, and I know exactly by how much. And then I know how much is going to affect the car's performance. And there are, we have 10 other variables in here that you could change. And this isn't just helpful for testing. This is also helpful for when we're designing the car. We don't have to go do the whole calculation in Excel. We can just quickly update in the MATLAB code, and then that'll help influence our design decisions for the car this year and for future years as well. So that's just a quick overview of my code.